Ladies and gentlemen, we will soon begin our conference. Please kindly click off your microphone and click your camera on. Don't forget to also set your phone into silent mode. Your cooperation is highly appreciated. Thank you. Assalamualaikum warahmatullahi wabarakatuh. May peace be upon us all. Good morning and have a good time, dear ladies and gentlemen. From Faculty of Fisheries and Marine Science, Jenderal Sudirman University, Purwokerto, on this lovely morning, we would like to welcome all the guests and participants in the second day of the 4th KRIPIK-SciFiMaS 2021. Praise is always be given to God for the blessings and guidance so that all can gather here in this room even though we are still in the middle of pandemic. Distinguished guests, ladies and gentlemen, before we start the conference, please allow me to inform you all the agenda we have today. We are going to have 2 expert speakers, and then the next are 2 panel sessions with amazing invited speakers. And we are also going to have online quiz for those who join this conference. And the last one, there will be the announcement for the best presenters of the parallel sessions.
Without any further ado, let us start our first session. Joining with us here, Dr. Dwi Susanto as our first expert speaker. This session will be led by Mr. Mukti Trenggono as one of lecturer is Fisheries and Marine Science Faculty, University of Jenderal Sudirman, with its highly competent is field of oceanography. Time is yours.
All right, thank you for a nice introduction for me. Good evening for Pak Dwi and good morning for audience. Okay, yes, unmute your microphone, please. Okay, Honorable Dr. Dwi Susanto and ladies and gentlemen, welcome to presentation today. Today we will listen the presentation from Dr. Dwi Susanto. I call him with familiar call with Pak Dwi. Maybe you will agree. Okay, thank you.
Sure.
Yes. Before presentation begins, allow me to introduce the guest speaker. His curriculum vitae for Dr. Dwi Susanto. Now, he is a senior research scientist at University of Maryland, USA, and he's also a young professor in Bandung Institute Technology. So many cruises led by Dr. Dwi Susanto, especially in Indonesia, and so many paper is published from Pak Dwi Susanto. Okay, Pak Dwi, today you will deliver the presentation with title Dynamics of Upwelling and Tidal Mixing in Indonesian Seas, and you will deliver around 25 minutes and then continue the discussion about 10 minutes. Without further ado, I would like to welcome the speaker to deliver the presentation, Dr. Dwi Susanto. The screen is yours.
Okay. Can you hear me?
Yes.
Okay, okay. Yes,
If you
good.
can try to slide.
Okay, just a minute. Good.
Yes, it's work.
Okay, good. Okay. Thank you very much, Pak Mukti. First, I would like to thank you for the invitation to the University of Jenderal Sudirman. Okay, so good morning to all of you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today, as Pak Mukti mentioned, that I would like to talk about the upwelling and tidal mixing in Indonesian seas. And please allow me, just let me know, Pak Mukti or Mas Mukti, 5 minutes before, so that make sure that I'm not over the time. Okay.
Okay.
So,
yes.
All my presentation you can download from the website. You know, there you can download the paper and everything is in my publication. You can just download there, and if you look at the Google Scholar, you can hit this one. Okay, so first, as you can see from this cartoon on the left, you can see that Indonesian seas is part of the global ocean conveyor belt. Okay, where Indonesian seas is linking the world ocean from the low latitude Pacific Ocean to the Indian Ocean, known as Indonesian Through Flow. And Pak Mukti, when he was in KKP, it's helped me a lot in terms of, and even join cruise with me many times, you know. So that way I already know very well. Okay, so that's why it is important that Indonesian Through Flow is not only important for global ocean circulation and climate, but also important for the biogeochemistry and nutrient transport from the Pacific to the Indian Ocean. Okay, so this is the cartoon in more detail, but if you want to more detail, this is the pathway of the through flow. So most of the through flow is through the Pacific, from the Pacific to the Sulawesi to the Makassar Strait, and then the eastern part is through the Liphamatula Halmahera. And then there is a western part that is through the South China Sea and the Karimata. And then that is just the more is general the input, but the output mostly through the Timor, Ombe, and Lombok. Though every strait in Indonesia is affected by the Indonesian through flow. So you can take a look at my paper in 2016 is the latest about the through flow. But today I will not talk about the through flow. As mentioned that I will talk about the upwelling. Okay. And then I added there, it's internal wave or internal tide. It's because of the submarine Nanggala. So hopefully it's not distract you to edit the internal tide and then the mixing. So you can see the upwelling basically is the upward movement of the coal and usually is rich nutrient to the surface. Okay, and then the internal wave is because it's so strong. Even this is ocean color, actually ocean color satellite can see the internal wave. As you can see, this look like this. This is the white, black, white. That is the internal wave. So that is very strong. And then the mixing is important is because when water before entering the Indonesian Sea, the TS or the temperature and salinity diagram look like this. But when exit to the Indonesian seas, it's become flat like that. That is the TS diagram. So that means along the way from the Pacific to the Indian Ocean, they have strong mixing within the Indonesian seas. The question is where? Okay. So as I mentioned before, this is what is the upwelling. So it's basically is usually it's because of the uplift of the water. So the surface will be cool SST, and then also low sea surface height or sea level, and then the chlorophyll is high. Okay. And then this is the basic, just to give you an example of the northern hemisphere. Even though you are in the southern hemisphere, we just flip. Okay. So suppose this is the coast, and then there's a wind. So because of the Ekman transport or Ekman spiral, this one. So when the wind is going that way in the northern hemisphere, the water actually going 90 degrees to the right of the wind. But in the southern hemisphere, it's just to the left of the north, to the left of the wind. So this is the cartoon of the northern hemisphere when the wind going along the coast, the upwelling there. But in the southern hemisphere, is when along the coast, the upwelling is actually going up there. The water is going to the left. Okay. So here is an example. If you have the strong upwelling is already known. This is very old paper. It's 2001. So it's like 20 years ago. Okay. You can see that along the southern Java and Sumatra, there's strong upwelling. So if you plot the surface temperature along Java and Sumatra, this is, let's say, along this coast. If this is from the near the deadline, sorry, near the equator, and then through the until the Lombok along the Java and Sumatra, and then this is sea surface temperature. Sorry. Oops. Okay, and this is the sea surface temperature. This is time, and this is longitude. So you can see that the upwelling is every 6 months. So the upwelling is induced by the monsoon. However, you can see that sometimes it's very strong, the upwelling there. Right? That is because association with the interannual variability associated with the ENSO and then Indian Ocean dipole. During the strong El Nino and strong Indian Ocean dipole positive, the upwelling will be stronger, let's say in here, and also here, there. And then in 97, you can see it. And then in 2006, actually in the 2022 is also very strong, but I don't have this figure. Okay. So that is the upwelling. So the upwelling is occur mostly during the southeast monsoon, for example here, the availing along the Java, Sumatra, and Nusa Tenggara is during the southeast monsoon because the wind is blowing this direction. And then because of the expand transport, so the water is going out there, so that will be filled out from the bottom. So it's a strong chlorophyll concentration. This is the chlorophyll concentration in the southern Java, Sumatra, Nusa Tenggara, southern of Borneo or Kalimantan, southern tip of the Makassar, and also eastern Banda and also south of Papua. Okay, and then during the other monsoon, it will be, this is become the used to be that upwelling will be downwelling because the wind is blowing that direction, so that the water will pile up, and then in the here northern of Nusa Tenggara it will be upwelling, but southern Java it will be downwelling because when the wind going this way, the Igman transport going that way, so the pile up along the Java and Sumatra. That by the availing during the northwest monsoon is only in the Malacca, and then in the northern Nusa Tenggara, and then also northern Papua. Okay, and then as I mentioned before, that the availing is strongly influenced by ENSO and IOD. This is example of chlorophyll in November 1997, and this is November 1998. It's the same November, it's the same monsoon, but because of different condition and so condition, this is during the El Nino Ido positive, this is during La Nina, so there is a big difference in terms of chlorophyll. So the Purwokerto is here, so this you also strongly affected by that actually in here. Okay, so the summary of the availing. During the southeast monsoon, the availing location is this blue line, this one. This is paper by Anindya, Pak Anin, Wirasatria in Undip, 2020-2021. Okay, and then the northwest monsoon, it will be in the Malacca Strait. This is paper by Mandal and also Pak Siswanto, and also along the Nusa Tenggara, and then along northern Papua. All this paper I collaborate with, so you can download this paper from my website. Okay. Now I would like to talk about the internal tide. Indonesia is strongly influenced by tide in two directions actually. One is that from the Indian Ocean is mostly semi-diurnal, meaning twice a day in peak, okay, peak twice a day and then trough twice a day, so semi-diurnal. Okay. However, from the Pacific is diurnal, is one cycle a day, so like one peak, one trough a day. That is from the Pacific. Therefore, in the inside of the Indonesian seas will be mixed between semi-diurnal and diurnal tide. So because of strong tide and then also the true flow, and then because of strong narrow passage and a strong stratification, that's why Indonesian seas may ideal place for the internal tide. But before that, just want to mention that because of strong semi-diurnal, the S2M2, it will generate the fortnightly like this. This is, like the black line, the arrow. This is 14 days, 14 days, 14 days. So this is kind of like nice, this one. But if you measure this tide in Cilacap or in southern Purwokerto, it will be even better, because this is in the Alor Strait, where there's combination of the semi-diurnal and diurnal. But if in the south of Java, it will be mostly only semi-diurnal only. Okay. So because of tides and then through flow and then stratification and then background current of the through flow and the topography, when this is hit the sill or seamount, it will generate mixing in locally, but also it will generate internal wave that and then when the internal wave break, it will be mixing. So that's why internal wave or internal tide is very important for nutrient, because the mixing usually where the nutrient is rich, and also where the internal wave breaking, that is the mixing, and also the nutrient it will be abundant. So where is the location of the internal wave? So if you see, this is the animation. Basically, internal wave can happen in everywhere in Indonesian seas, in the deeper one, except in the Java Sea and Kalimantan. But the rest is basically is everywhere. That is the internal wave. For example, Lombok, you see the generation is in there, can going south or going north. Right? So that including the Sulu Sail, even the Natuna Sea, and you can see in the Andaman and also in the Malacca Strait. So that is the so the internal wave is very important for enhancement of nutrient. So I have to move this one, I think. Yeah. So that way it is important dynamic for the nutrient concentration. That's why Indonesian seas is very rich, because of one of them is because of the internal wave. And then the question is, can we see the internal tide or internal wave? That I saw you before. That is from the satellite ocean color or MODIS or sea wave. And this is from radar. This is active microwave. You can see the internal wave. That is white and then black, then white. Right? This is generation area is in the Nusa Penida area, the cell here. The Simon is in here. Because this is deep and then shallow and then deep. Okay. So the wave can going northward, southward, and then going both direction. Okay. And then the question is, well, this is from the satellite. What is the internal wave look like at sea or below the ocean? Because internal tide is actually not in the surface. It's like a gravity wave or the wave that we can usually see. This is actually the wave is in the below the ocean. So it's like on the thermocline or pycnocline. You can see the wave is like big like this. This is the amplitude from 0 to 150 meter. And then this is 30 minutes. So the black line is 6 minutes. So if you dive in the Lombok Strait, for example, in 25 meters, 6 minutes later you will be in 75 meters. 6 minutes later you will be in 130. So basically you will not survive. You know? So the same thing, this is important for submarine, because if submarine is fully trimmed, meaning that buoyancy is 0, meaning it's very buoyant, it's like egg on the salt water, it will be going like this. The same thing, the submarine going up and down like that. So that way it is very dangerous also for the submarine. So the question is, why we can see internal wave from satellite? So this is the same. I just want to show you, sorry, before. Yeah. Okay, here. You can see that the wave is very big. It's 150 meters. If you compare to the Tugu Monas in Jakarta, it's only 132 meters. So this is even taller or bigger than Tugu Monas. So that's why it is very big. And then how we can see from satellite, this is the same. I just want to show you that the wave is going that direction. The region in here next to the peak is the convergence zone. And then the next to the second peak, it will be divergence zone, and so on. So the convergence zone, the surface will be very rough. Actually, you can see it from the ocean. If you cross ferry from Padang Bay to Lembar, for example, you will see this kind of like this. This very rough and then smooth, and then rough and then smooth. That is actually internal wave. That is when you see this, you know. So that's so because of very rough, when they have sunlight, will be reflected all direction, so that can be captured by the satellite. So this will become bright color. This is dark and then bright and dark and so on. So that way you can see it from the satellite. But you can see also from the ship radar, the captain can see not only by the eye, but also by the radar, ship radar. You see it there. The internal wave is like that on the screen of the ship. Okay. So as I mentioned before, this is the MODIS, the ocean color. The next question is, can we predict the internal tide? So that, yes, when there is strong tide, it will generate the internal tide. So usually internal tide is generated every 2 weeks. You know, when we see the as I mentioned before, the tide is fortnightly. So during the spring or neap tide, it will generate strong, especially during the spring tide. Why internal wave important? It is because if there is no stratification, easy to detect, submarine, for example. But there is internal wave, the sound speed is changes, the stratification is changes. So it's not easy to do the detection of internal tide. And I forgot to mention to you, this one, right? This is actually echo sonder and fish finder. So the blue, this is actually nutrient or the zooplankton, because it's very small, that reflect the sound or the sonder, because this is echo sonder, or like, so that you can see the internal wave from fish finder or echo sonder. Okay, that way the nutrient also going up and down in the internal wave. That's where that is very important for you. The next question is about the mixing. The question is where the mixing located. So the simple relation is that the changes in sea surface temperature is related with the square of the velocity. So using those and then using high resolution SST, actually we can infer where the mixing located. Okay. So here is using multi-high resolution sea surface temperature, because the resolution is 1 kilometer by 1 kilometer and every day. So this is big file. This is because 1 kilometer by 1 kilometer and then 20 years of data. So you can see, and then each pixel, each time series, and then you do the Fourier transform or harmonic analysis, and then select only the frequency of 14 days or fortnightly, 14.77 days. Okay. And then from there, you plot it, and then you can see this one. This is only at frequency 14 days. You can see that the mixing is not in the Bandasi. Bandasi is not strong mixing. The strong mixing is in the Sulusil and then along the Nusa Tenggara. Okay, the Bandasi is not, and then Livamatola is kind of like moderate. If I zoom along the Nusa Tenggara, you can see that is the location. The red is the location inferred by the satellite. You know, if you process the satellite of SST, you can see that this is where the location of the mixing. Okay, so based on the numerical model, also this is by Nagai 2015, that the mixing is also in there. So the same like what we did in our paper in 2016 and 2019. So that's why in early this year, in March 12 to 20 and 27, 2021, in collaboration with LIPI and then KKP and First Institute of Oceanography at Maryland University, where I work, we try to validate this mixing. Okay, that way we spend only 2 weeks in this star, it's like 15 days, to show that if indeed the mixing is very strong. So we just do this using microstructure profile. Okay, that is special instrument to do the mixing. And you can see that from here is the TS diagram, temperature, salinity, and density. You can see at 100 meter is very strong stratification. And this is the dissipation rate. And this is the Bundsala frequency. And then this is the diagonal diffusivity of the measure of the mixing. And the mixing is very strong. because 10 to minus 1. Usually open ocean is 10 to minus 4 or 5. So that means 10,000 times. So that way it's very strong mixing there. So so that the satellite has been validated with the observation. So this is almost end of my slide. So hopefully it's not over the time. So that because we need to monitor the true flow continuously, and then also we would like to estimate the biogeochemical flux and nutrient flux associated with the true flow, and then also the biomass, biodiversity with the true flow. And then also we would like to see the causal effect of the upwelling to the true flow and also ENSO, and then to validate strong tidal mixing. That way we have the program called TRIUMPH. It's True Flow Indonesian Seas Upwelling and Mixing Physics. This is our collaborator. Okay, and the first cruise that we did in 2019, we deploy mooring in the North Makassar and the Lombok Strait. That is to measure the mixing. To measure the true flow. And then we do have a mixing in here, measurement. And then we have mooring in the south of Java and Sumatra, south of you actually. South Java. That is to measure the upwelling. And then we have a Rama or Pelong V mooring there in here. That is to monitor the Indian Ocean dipole condition or the climate condition. So this TRIUMPH cruise is multidisciplinary. So it's not only physical oceanography where we have the mooring. Okay, this is Pak Mukti is already well known about this because helped me a lot in the Karimata Sunda. And then we have, this is the microstructure that I mentioned. Okay, this to do the mixing. And then we have the XCDD. We also have a aerosol, it's from BMKG. And then we have the sediment core. We have plankton. We have bacteria, microplastic, PCO2, and biogeochemistry. So if we have a complete multidisciplinary cruise in order to understand the true flow, the upwelling, and mixing physics in Indonesian seas. So in summary, most upwelling in Indonesian seas occur during the southeast monsoon, but there are some locations, for example, Malacca Strait, north coast of Nusa Tenggara and Papua, the upwelling occur during the northwest monsoon. And then due to complex coastline geometry and narrow passages and strong tidal current and true flow, Indonesian seas are ideal place for internal wave generation and mixing. Internal wave is very important for navigation as well as submarine. So it is opportunity, but also challenging. Opportunity because we can do exercise hide and seek for the submarine. Okay, but challenging is because it will be very a challenge in terms of locating the submarine, but also important for the nutrient because where the internal tide located, usually they have a strong tidal mixing, and then that's enhancements of the chlorophyll concentration. So last but not least, the dynamic Indonesian seas are very complex, and Indonesian seas play a pivotal role in regional and global ocean circulation and climate and biogeochemistry. Therefore, we need to have synergy and collaboration among marine scientists from various disciplines, not only physics, chemistry, biology, geology, and geophysics, fisheries, and engineering, even pharmacies, because there's marine natural products, and also that's good for cosmetic and also medicine. So that way we need to have those collaboration. So thank you very much. Appreciate your attention. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. All right. Thank you very much for nice presentation from Pak Dwi. All right, ladies and gentlemen, now we will start the discussion. Unfortunately, we just have, I think, around 6 minutes. So maybe we will offer 2 or 3 questions. If the participant want to ask directly, please raise your hand, or you can write in the chat box. Okay, let's see. Right, Badwi, maybe wait for a question from participant. Maybe I have one question, especially about 3 phenomena that you have mentioned about upwelling, and then about mixing, and about the tidal. So what is anything important that we need to study upwelling and then tidal, also mixing? Maybe is there any relation with fisheries?
Yes, it is very strong. Maybe I'm not very clear. Okay, so of course the upwelling is the location of the phytoplankton growth. So that where the South Java and Sumatra is very famous for the upwelling, and also famous for the fisheries, because fisheries or fish is like the phytoplankton bloom, isn't it? So that's the location of the upwelling. And after upwelling is mixing. Usually the mixing location is where the phytoplankton bloom, because the mixing, if you have the water column, okay, and then you have the you have the chemical and also solar, then you will have phytoplankton growth. But if there is no mixing, after a certain time, it's run out of food. So that way you need to have a mixing. Otherwise, there is no food anymore. That's why the mixing is very important. So that's why the mixing along South Sumatra and along Nusa Tenggara is very important. That way there is the location of the tuna hatching, isn't it? Because the tuna like to eat small fish, and the small fish is located in the southern Java and Nusa Tenggara, because they're the location of the mixing and upwelling. That is very important. And the internal tide is in hands of those mixing. That's why it is important to understand that's why I choose the topic of upwelling, mixing, and internal tide, especially related to fisheries directly. Okay.
Right.
Hopefully answer your question.
Yes, very complete your answer, Badwi. Okay, we move to next, maybe the last question from audience. We can see in the chat box. The question from Ms. Cecilia Rani, maybe I want to read. Based on your research using satellite imagery, monsoon and extreme climate impact on chlorophyll A, has there ever been a research collaboration that took samples directly on site to determine the structure of phytoplankton community due to these impacts? Maybe there's a phytoplankton division that dominates. Okay, Badwi, please.
Okay, thank you. Sorry, I share you again. Hopefully you can see. Okay. You still see it, Pak Mukti?
Yes.
Okay.
Alright.
Yes, you can see from here. Sorry, let me close this. That we not only measure on a plankton, but we measure biogeochemistry PCO2 bacteria. So we did. You see this, all this point, this is we measure it. So yes, but we just finished the cruise, recovery cruise early this year from January to April 2021. And most of this is part of the dissertation and master by the LIPI and KKP scientists, so that they are doing it. So yes, we measure it. This is plankton net. So yes, we measure it. So of course, we will publish when we finish all the analysis, not only biogeochemistry, but also about the bacteria in the southern Java and along the Makassar, and also the microplastic, and then PCO2. Okay, so hopefully those answer the question.
Right, Pak Dwi, thank you very much for complete answer. Okay, unfortunately, our time is limited, so now is we will end the session. Although there is one question, maybe we'll ask directly to Pak Dwi by email, maybe from Titin. I think
Sure,
Pak
no
Dwi will
problem. Yes,
welcome.
you can contact via email.
Okay, thank you.
Yeah, yeah,
Okay.
or you can download all paper in my website. So all those paper that I presented is in there, so you can download there. Okay.
Okay, thank you, Pak Dwi.
Thank you very
ladies
much,
and
Pak Mukti.
gentlemen,
So thank you very much for
finally
inviting
we
me.
come to the end of presentation. Before I end the presentation, here is the certificate from committee for Pak Dwi as our appreciation for Pak Dwi as expert speaker today. You can refer it.
Oh, thank you very much. Appreciate, and I like the appreciation, the KRIPIK. Yes,
Yeah.
I wish I can come to Purwokerto again, because in 2015 I visit your campus. So hopefully next year I can visit again. You know, so
Yeah.
I like the
Yes,
KRIPIK
please.
and also the KRIPIK-SciFiMaS. So that's very good. You know, so
yeah. Okay. Thank you, Pak Dwi. All right, ladies and gentlemen. Now we finish the presentation today. Thank you very much for your attention. Thank you for Pak Dwi. See you in the next seminar maybe.
yes.
Okay. Thank you very much for all. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for giving us such an interesting presentation and discussion, dear Dr. Erdu Susanto and Mr. Mukti Trenggono. So here come the last expert speaker session with the amazing Professor Dr. Choi Jae-suk, and we're going to discuss about biotechnology. Joining with us here, Dr. Maria Diah Nurmenita, SPI MSc, as our moderator in this wonderful session. Dr. Maria Diah Nurmenita is an associate professor in marine biotechnology, Jenderal Sudirman University, who is definitely highly skilled in her field. Dr. Maria Diah Nurmenita, time and screen is yours.
Okay, thank you very much, Ms. Britannia and Ms. Annie, for the very nice introduction. Good morning, according to Indonesian time, and good afternoon, according to Korean time, because here in Korea is 2 hours different from Indonesia. Korea is 2 hours ahead from Indonesia, so actually it's lunchtime here. And ladies and gentlemen, first of all, I would like to welcome you to the expert speaker, the second session for today of the 4th KRIPIK Scientific Communication in Fisheries and Marine Science 2021, which organized by Fisheries and Marine faculty of Jenderal Sudirman University, Purwokerto, Indonesia. Well, in this session, we are lucky we are having Professor Che Jesuk, who will present his expertise in fisheries biotechnology field. And before Professor Che starts his presentation, please allow me to introduce Professor Che Jesuk. Okay, as we can see on the screen, Professor Che Jesuk is a professor from Department of Food Biotechnology, College of Medical and Life Science, Silla University. Fisheries, he also assigned as a fisheries as a vice director of the Fisheries Research and Development Center, Silla University. And Professor Che is very productive in conducting research and publishing so many scientific papers. To date, he published about 159 international research papers, which either indexed by SGI and SGIA. And on the screen, we can see there are the 3 newest papers he published recently. Well, we must be very proud because those papers are involving 2 alumni of the Fisheries and Marine Science Faculty, General Sudirman University. Bertoka is an alumni of the Marine Science Study Program, class 2008. And now he's taking a doctoral degree here at Silla University. And Gabriel Tirtawijaya is also an alumni of Aquatic Resource Management Study Program, class 2006. And now he's working here as a researcher. And this year, I also collaborate with Professor Che and publish some research paper. Today, Professor Che will present a very interesting topic entitled Latest Technology Trends in Fish Processing, Application of Processed Marine Product. So as I mentioned before that currently Professor Che is also assigned as the Assistant Director or Vice President of Industry Academy Cooperation Foundation, Fisheries Research Development, Silla University. And this research center collaborates with many fisheries, marine and seafood industries in Indonesia, in Korea, I mean. So we can also see some of the product that they produce in Professor Che presentation, and we will learn many things about the latest technology in the fish processing. Okay, without any further ado, I would like to welcome Professor Che. The screen is yours.
Okay. Thank you for introducing me, Dr. Maria. Selamat siang. I'm very glad to meet you. My name is Jae-seok Choi. I was professor in Silla University in the Busan city. Busan is the second largest city in South Korea and have many seafood processing companies in their harbor. Through my many research with these companies, I have learned that the food industry is closely related to the processing machinery industry. So I would like to introduce the latest technology of seafood processing. Namely, I intend to overview the latest technology trend in fish processing. My presentation content is as follows. First, domestic seafood company stature in Korea. Second, food industry is closely related to equipment industry. And then microcontrol technology, frozen, heating, dowing related technology, and smart factory. In an aspect of the seafood consumption stature in Korea, the many food processing companies complained of the management difficulty, which are closely related to the decline of consumption of seafood in Korea. As you can see the red line. Why the consumption of the seafood reduced? main cause, as you can see, the fish smell, the internal bone, the smoking generation, the cleaning cookware, and the byproduct. Because of this problem, an increased rejection trend has been seen against the fish cooking in the group meal as well as in general home. In addition, social structure of Korea is changing towards a single-person household because working women and the aging population increase. Actually, the Korea is aging faster than the Asian countries. Therefore, they don't want to cook at home, and the market size of the HMR steadily increasing. However, as seafood product is considered the healthy food, having the omega-3 fatty acid, taurine, no cholesterol, so the demand of HMR using seafood is increased. Well, in my opinion, on advanced marine processing technology essential to the product high value added fishery product. Most important, hygiene and safety and the preservation of flavor, nutrition, shelf life extension, and convenient meal is very important to our the target research area. Development of the advanced fish processing in line also needed in Korea. Why do you need it like this? Due to rising the minimum wage, faculties are trying to use less manpower, and then they also emphasize more than the machinery and equipment. So many faculties became unmanned or automated. Yes, first is high pressure processing to control in the aspect of microbial control technology. The basic principle of high pressure processing is to destroy microorganisms and viruses at high pressure up to 900 megapascal. Advantage is HPP included extension shelf life with no heating treatment. Very important, no heating treatment. Recently, studies has been actively carried out to apply HPP to seafood product. For example, all of organism, microorganism in shrimp paste was destroyed at 300 to 400 megapascal. In Korea, the HPP already applied to fresh juice, fruit juice, cold brew coffee, and the various HMR products. Let's watch a related video. First, put the product into the vessel. The vessel then moves the frame and fill with the water. The vessel pressurized food product 6 megahundred pascal. Then drained water. It's the pressure. Yes, HPP manufacturer told us HPP can provide several solutions for seafood processing. Yes, like this advantages provided. Yes, this is lobster. This is a very important, very interesting example of applying HPP to aquatic product. What if HPP applied to lobster? Yes, as you can see, the yield increase without loss. Similarly, applying to the oyster, sponges will separate then shell and flesh like this. Okay, the advantage, more you can see, but this advantage of HPP, high capital cost for HPP system, and the shell pieces and the two soft tissues cannot adapt to this technique. This technique is needed to high maintenance and the operation cost. Next is the pasteurized technology. Post-light technology is short-term time high peak burst of the broad spectrum, including the white UV visible light, and the used then the inactivate microorganism on the surface of the food packing materials. Let's watch a related video. The left is control, right is treated. Yes, after treating first light, although many microorganisms are detected in the control, otherwise almost microorganisms were sterilized in the treated group. Yes, the example. Fish slice input the small scale of pulsed light generator for the research purpose. Yes, light. Yes. The pulsed light is treated. Yes, as you can see, the cell wall of microorganism treated the first light is the punctured. Thus, these microorganisms will die. The next one is the ionizing irradiation, gamma ray, electron beam, X-ray. Above mentioned UV can only sterilize the surface, but gamma ray penetrates the food and packaging materials and sterilize all body. That is very important.
Products are carefully loaded onto a material handling system. They are usually put inside aluminum carriers or totes. Each load is designed to ensure the specified dose is delivered. Then, process monitoring devices called dosimeters are placed at previously determined points on the product to measure the delivered irradiation dose. Next, our specially trained and certified operators enter and verify the product-specific cycle parameters in the control system, and the cycle begins. The carriers travel by conveyor through a concrete maze that separates the non-processed area from the irradiation chamber.
Gamma ray comes from
Inside the
cobalt-60
irradiation chamber,
isotope.
the cobalt-60 isotope, often called the source, is contained in encapsulated pencils that are carefully arranged in a specially designed rack. When not in use, the source rack is submerged in a storage pool of deionized water. This shielding allows the production and maintenance teams to safely enter the chamber as needed. With the gamma source rack in the raised position, the carriers enter the irradiation chamber. Each carrier passes by both sides of the source rack, ensuring even exposure. Length of exposure varies by product and predetermined dose range.
Yes, gamma ray are widely used to sterilize food for newborn, patient, and astronaut, as they need the completely sterilized product. Next section is the freezing relay technology. I introduce first is electromagnetic freezing technology. What if we put the water in the glass bottle and freeze? Of course, it will be break. Why would the glass bottle break? As you know, when water freezes, the volume of the ice expand and then glass bottle is break. Similar phenomenon is observed in the cell. So when cells melt, drip occur. So the texture is product will fail. However, when a product is subject to a strong electromagnetic field, during freezing, the water molecule is of the product freezing alignment like this. Thus, expansion of the ice volume minimalized, and then the cell membranes will not break. When the product melts, the drip is minimized, and texture of the product does not destroyed. You can see the photo. It's a slow drawing. You can see the large size of the ice crystal, but like is the electromagnetic treated the very smaller with the ice crystal size.
鍵は細胞の中にある水の分子。食べ物を冷凍すると、この水の分
Yes,
子が
this is the conventional freezing.
細胞の壁を壊し、解凍した際、旨味を外に逃がしてしまう。そこで冷凍する際、磁力などを使って分子の
Yes, strong electromagnetic field treat. The ice crystal size is reduced.
冷凍機を試作。再びマグロの冷凍に挑んだ。
This person is inventor of this
解凍すると出ていた旨味を逃がしてしまうドリップがごくわずかのように。
You can see the clearly the less amount of drip into the electromagnetic field treated frozen and the melted fish.
それを叶えるのが冷凍しても味が落ちない二宮の冷凍機だ。その性能を最も実感できるのがお刺身だという。生と冷凍の比較実験をしてみる。さばいた直後のマグロを二宮の冷凍機で凍らせた後解凍。
Respondents were asked to compare the fresh tuna in raw and frozen through the electromagnetic
ど
field.
ちらが冷凍したマグロか当ててもらう。
Yes, the frozen and melt.
協力してもらったのは地元の短大の学食にいた皆さん。一般的に冷凍すると食感や旨味が落ちると言われていますが、さあどっち？
食べた時の食感がなんか、それが冷凍かなって。
あんまり違いわかんないですね。どちらが冷凍マグロだと思いますか？
Surprisingly, the people could not distinguish between raw tuna and frozen tuna.
答えはほぼ半々。どうして冷凍を見破ることができなかったのか。専門家に協力してもらい、科学的に分析してもらった。
Yes, when measuring the resilience of the raw and frozen tuna in laboratory,
数値で比較してみる。家庭用冷凍機のマグロはべちゃっとして弾力がなくなるが、二宮の冷凍機のマグロは生マグロに近い弾力が残っていた。
yes, the resilience of the frozen tuna kept the resilience similar to raw tuna like this. Next technology is the pressure shifting technology. You can see the micrograph of the turbo plate frozen by the air blast control in minus Celsius, 20 Celsius degree, and by pressure release from the 100 megapascal at minus 40 degree. A smaller size of the ice crystal observed in the pressure shift freezing group. The ultrasonic freezing also introduced. As you can see, the ice crystal size is in the treated ultrasound is smaller than that of the control. Vacuum cooling is mainly used for the vegetable, fruit, and flower. But nowadays, this technique also introduced the meat processing technology and seafood processing technology. The figure presents typically cooling curve of the large meat product cooled by the different method. This line is vacuum cooling. This is the common cooling needed is above the 12 hours, but in the vacuum cooling group, only needed 2 hours. Yes, You can see the video.
Vacuum cooling has long been recognized as the most efficient method available for cooling most fresh produce items. And with over 60 vacuum cooling units all over Australia, QuickCool is the nation's leading vacuum cooler brand. The QuickCool product is designed, built and serviced in Australia and can be tailored to fit your specific cooling needs. We've been servicing Australia's leading vegetable growers for over 20 years, so our vacuum coolers offer some unique, innovative design features which maintain high performance, reliability, and long-term life.
Yes, nowadays the usually apply the vegetable product, but we researched to how to apply the seafood product. Yes, at first I would like to introduce superheated steam roasting technology in heating relay technology. The water boiled 100 Celsius degree and changed to water vapor, but these water vapor are usually used for steam food. However, when water vapor are reheated the temperature above the 350 Celsius degree, and the produced gas is called the superheated steam. This superheated steam can roast food, not steam food. Perhaps this video will make it easy to understand the superheated steam. Yes, but this is a normal water vapor, and reheat using the like this, reheating to above the 300 Celsius degree. Yes, this gas is show the transparency. But temperature is very high. Yes, like this, the burn. Likewise, when the superheated steam come into the contact with the food surface, it condenses into water drop, so the baked food become softer. People who like the soft food and the elderly would be like it. Next is the ohmic heating. Ohmic heating called the joule heating, electric resistant heating, or the electroconductive heating. This process components of the stimulate the steam of the food quality, food, liquid, and solid by passing the electric current through them. Yes, this video is a very basic model of ohmic heating. The source is connected to the both electrode and left the electric current is flow. Yes, like this, you can see the source is lightning because the heat generation. Okay, next. Microwave processing also very interesting. The basic principle of microwave heating is not different from that of home microwave opening. This video is about the actual application of the micro heating oven. But what is different from the other heating method? Let's think about it. Yes, micro heating is also possible for packaged product. Whereas the product processed during the other heating method must be packed after heating. Yes, due to time. Yes, high frequency defroster has been developed as the drawing related technology. Generally, when seafood products are melted by put them at room temperature or in water, the core portion does not melt at the same rate. So the surface melted first and the microorganism multiplied. Otherwise, the high frequency diffuse to melt both inside and outside at the same time. So lateral drawing is needed to 24 hours in water, 12 hours, the mist drawing 9 hours, and then like this, the microorganism will be detected. But if we treated the high frequency diffuse, only 10 to 40 minutes is needed. And the Listeria and E. coli is not detected. It's also a very good merit. This is the tabletop radio frequency diffuse for commercial restaurant. Yes, the core side in the temperature core 9 Celsius degree. Within minutes, the both outside and core do at the same time, like this. Yes. This is PPT is the advanced PC processing line. The Balka is the very famous company in Iceland.
Looking for ways to make the production process more efficient and to meet growing customer demands. The Valka Advanced Processing Line ensures more profitable fillet production with exceptional quality, less labor, and increased product quality. The Valka pre-trim line is specifically designed for gentle handling of the raw material. We use push-off instead of pneumatic arms, and extra-wide trimming stations guarantee that the first fillet in is the first out. If there are no defects or parasites, the fillet goes directly to the Valka cutter machine.
Yes, this system is very interesting.
The Valka cutter combines cutting-edge technology in regards to both the software and hardware combination. It scans the fillet with a high-speed X-ray camera to accurately locate the bones. A second measurement is performed with a 3D vision camera for accurate weight of the fish.
Yes, that is very important.
This guarantees more precise portions and ensures optimal utilization of the entire fillet. The cutting is performed by water jets that provide extremely flexible and exact cutting for the smallest to largest fillets, skinned or skin-on. Because of the flexibility of the water jets, the possibilities of cutting patterns are limitless. And the system makes sure you get the right portions and the best value for each fillet.
Yes, next step is the sorting by weight and size.
The cutter are categorized by weight and size. They can be routed to the appropriate channels. The products flow in a continuous stream and maintain their correct alignment to the next stage. The Valka aligner grades, batches, and automatically aligns the products in the final packaging. Each piece is accurately weighed, measured, and carefully transported into the machine. The unique carousel system and advanced grader software enable identification of up to 16 pieces on its way to the packaging. Therefore, the system can make optimal selection of pieces for each box and virtually eliminates any giveaway.
Professor J, the time is almost finished.
Yes, I'm sorry. I failed to manage my time, but this is my lab member. And thank you for my presentation. Okay. Yes. Have you seen that? Of course, all of these technology requires a sufficiently preliminary research to be used to target seafood.
Okay, sorry, I couldn't unmute myself. Okay, thank you very much, Professor Che. Let's give a big applause for Professor Che. It's really enhanced our knowledge and insight on the latest technology in fish processing. Unfortunately, we only have maybe 1 minute left, so I can only maybe allow one question. And in the chat box, there is one question, Professor, that we can maybe we can discuss from Mrs. Abhinawanto. Which is the best technology to preserve the fish product related to the taste and food safety? Mrs. Abhinanto is from Universitas Indonesia.
I'm sorry, I did. Pardon?
Yes. The best technology to preserve the fish product.
Yes, depending on the fish species and size, is the preservation. More size of the company on more depending on size of company, the fish depending on fish space will different. The preservation will be the freezing is the best, but the as you know the freezing if frozen fish they reduce the quality. So nowadays the hybrid ice technology already introduced in Japan and Korea. So hybrid ice is the minus 35 ice with the salt. There is the very latest technology to the preservation of fish, the short time. So the if you need the more the information, please send to my email. Okay.
Okay, thank you for the answer, Professor. So it's depend on the fish species itself.
Yes.
It's fish species. They have a different method to to keep the taste and the food safety quality also. Okay, thank you, Professor.
Okay.
Because
the line is not connected to the short time, so I not heard your comment. But anyway, thank you.
Yes, Professor. And the other question may be, they may send you to your email, or they can send me a message. Then I will can inform you about the other question. Okay, it's really enhance our knowledge and insight on the latest technology in fish processing. And also, as we noted, Indonesia one of the top producer of fisheries research in both fisheries capture and also aquaculture, but the technology is not that developed compared to Korea. So finally, Professor, we come to the end of this session. So on behalf of the committee, we would like to give you appreciation. Thank you, Professor Che, for sharing your knowledge to us. It's really give us a new insight for us how to apply the latest fisheries technology. And hopefully we can produce Indonesian also can produce many fisheries and marine products from Indonesian fisheries and marine resource. And let's give one more big applause for Professor Che. Thank you, Professor. Terima kasih.
Yes,
Kamsahamnida.
thank you for your attention. Yeah, thank you so much. Yeah.
And this is the certificate for you, Professor.
Thank you so much for the certificate. I wish to you all the best. Terima kasih banyak.
Terima kasih. Kamsahamnida.
네, 감사합니다. Thank you so much.
Okay, thank you. This is the end of this session. I will hand over to the MC. Thank you very much.
Such an amazing session. Professor Joy Jaisuk and Dr. Maria Diah Nurmenita for giving us more knowledge about the technology trend of fish technology and processing. It is the time for us to move on to our next agenda. We will have two parallel sessions for today. The first one is an engineering topic.
For the second parallel session, we will start at 1 until 3 p.m. Jakarta time. Last but not least, we are going to have Dr. for aquatic biodiversity and ecosystem topic. Those who are interested to listen to the presentation of our invited speakers, you may join the breakout room. Dr. Emily J. Frost will deliver her presentation in breakout room Halistoma. Satria Kautsar PhD will join breakout room Puntius. And in the second parallel session, Dr. Chaya Chowdhury will be in breakout room Halistoma. Please take notes that participants are requested to change the username into your name, and for the moderator, you may change it into MDR_ your initial room name _ your name. Please take note that participants are requested to change the username. For the participants, you may change into your code _ and for the moderator, you may change it into moderator _ your initial room name _ your name, and for the PIC room, you may change it into PIC _ initial room name _ your name. As the parallel session begins, all the participants and presenters may join the breakout room and return to the main room at 3 p.m. Jakarta time. If you have any trouble to join the breakout room, let us and the commenter know by via the commenter or the chat box in this Zoom room. Don't forget to return to the main room at 3 p.m.
Sebuah mimpi tidak akan terwujud dengan begitu saja. Butuh kecerdasan, upaya, dan keberanian untuk menggapainya. Kekayaan alam yang melimpah serta keragaman budaya di Indonesia menantang kita untuk dapat memanfaatkan, menjaga, sekaligus melestarikannya. Untuk itulah, Universitas Jenderal Sudirman hadir dengan memberikan lebih dari sekedar pendidikan, tetapi juga sebagai wadah untuk pengembangan sivitas akademika agar mampu menaklukkan tantangan dalam kehidupan. Terletak di kota Purwokerto, Universitas Jenderal Sudirman menjadi tempat yang aman dan nyaman untuk belajar. Aksesnya pemuda, membuat UNSUD menjadi tujuan pemuda dari berbagai penjuru dunia untuk meraih cita-cita. Keindahan bumi pertiwi menjadi anugerah yang menciptakan energi positif untuk pengembangan diri. Universitas Jenderal Sudirman memiliki komitmen menyelenggarakan pembelajaran berkualitas untuk menghasilkan lulusan yang berkarakter dan berdaya saing tinggi. Pendidikan, penelitian, dan pengabdian kepada masyarakat dilakukan dengan semangat untuk mewujudkan visi diakui dunia sebagai pusat pengembangan sumber daya perdesaan dan kearifan lokal. Kami percaya visi tersebut dapat diraih dengan kemitraan antara UNSUD dengan lembaga-lembaga yang memiliki harapan yang sama untuk menciptakan masa depan yang lebih baik. Didukung dengan sistem digital yang sudah terintegrasi, Universitas Jenderal Sudirman mampu memberikan pelayanan yang ramah dan cepat bagi seluruh sivitas akademika. Dengan sarana dan prasarana yang berkualitas, serta tenaga pendidik dan kependidikan yang kompeten, kami bersinergi membangun reputasi guna mengembangkan penelitian dan inovasi unggul untuk pengembangan ilmu dan peningkatan daya saing bangsa. Berjuang untuk menciptakan pribadi-pribadi tangguh, pemimpin masa depan. Karena kami sadar, semua orang memiliki hak yang sama, apapun latar belakangnya, untuk membangun negeri tercinta. Dan inilah kami, Universitas Jenderal Sudirman.
Hello, good morning, Emily.
Sebuah mimpi tidak akan terwujud dengan begitu saja. Butuh kecerdasan, upaya, dan keberanian untuk menggapainya.
Hello, Emily.
Kekayaan alam yang melimpah serta keragaman budaya di Indonesia menantang kita untuk dapat memanfaatkan, menjaga, sekaligus melestarikannya. Untuk itulah,
Hello, good morning, Emily. Good afternoon there. Yeah, Emily, can you hear me? Ask to unmute, Emily.
Oh, yeah.
Okay.
Hi.
Hi, how are you?
I'm good. How are you?
Good, thanks.
Good.
Emily, could you please go to the breakout rooms? And
Okay, so
then,
how do I do that?
yes, choose the helostoma.
So how do I go to a breakout room?
Sorry, one second here. Sorry, yes?
How do I go to a breakout room?
You know, there's a record, what is it? Tumble there. What is it? Oh, bisa dibantu. Oh, I think the committee can help you.
Oh, okay.
Okay, awesome. How are you? Thank you so much for joining us today.
Oh, there we go.
Yes.
Halo Mbak, saya juga bisa dipindahkan ke topik 2.
Dengan Bapak siapa?
Pak Dwi Susanto.
Oh ya Bapak, mohon maaf Bapak.
Gimana caranya nggak tahu.
Iya. Topik 2.
Yang Pak Kausar, Satria Kausar.
Pak Kausar Satria ya. Baik ya. Bapak.
Terima kasih.
Ya, terima kasih Bapak. Okay. For everyone who hasn't joined any room, please choose any room that you would like to attend. Jadi boleh milih breakout mana saja.
Udah masuk kamu? Masih tetap di tadi. Saya tetap di tadi. Sudah di breakout. Oh, kamu sudah di sini. Nah, sudah. Jika kamu belum, loh ini udah pindah berarti. Suara saya tuh. Assalamualaikum Ibu, mohon maaf, saya belum di breakout room Bu.
Ini ya Mbak, yang di sini Mbak.
Siapa ya? Uswatun Hasan.
Mau masuk ke mana?
Mau masuk ke yang CTS 2 itu.
Aktinia sesi 2 itu nanti jam 1 ya dimulainya. Sekarang silakan bisa memilih breakout room manapun untuk mengikuti presentasi.
Oh iya, terima kasih Bu.
Ya.
Oke, Ibu, mohon maaf, panitia mohon informasinya, nggih.
Ya, gimana Ibu?
Untuk yang season 2 itu sesuai dengan jam 1 atau kita breakout ke sesuai room yang ada di Zoom ini, Bu?
Ya, jadi untuk sesi kedua akan dimasukkan mulai jam 1 Ibu breakoutnya.
Oh, nggih, paham. Oke,
Ya.
terima kasih, Bu Dahuri.
Ya, sama-sama. Terima kasih, Ibu. Boleh bergabung di room yang lain, Ibu. Silakan kalau mau mengunjungi.
Oh, oke.
Atau mau mengikuti di room tersebut terlebih dahulu juga tidak apa-apa.
Bu, mau nanya, Bu. Cara join roomnya gimana, Bu?
Oh, Bapak, silakan ke breakout room yang di samping tombol record itu, Pak. Ada. Bapak mau pilih di unassign itu, silakan diklik ke bawah, terus di situ ada ruangannya. Bapak mau ruangan Hello Stoma atau
Gimana, Bu? Gimana? Di dekat tombol record.
ya, itu ada breakout yang tanda kotak 4.
Nggak ada, Bu.
Boleh dimasukkan mungkin panitia? Boleh dibantu dimasukkan, mau ke ruang mana Bapak?
Hello Stoma.
Hello Stoma. Namanya siapa Bapak?
Misi Bu
Muhammad
Turi.
Siddiq Asyari Firdaus.
Firdaus.
Muhammad Siddiq
Itu
Asyari
di more ada titik 3 bisa ke sana itu Bu Turi.
Gimana?
Itu ada titik 3 yang more, mungkin partisipan bisa milih di situ yang more, kemudian ada menu breakout di situ. Pakai menu
gitu.
titik 3.
Oh, titik 3 ya. Mungkin
Ya, yang di
tampilannya
kanan
agak
bawah.
sama ya.
Kanan
Silakan
bawah
Pak
itu.
Mukti boleh dibantu Pak.
Ya. Mungkin yang belum bisa menemukan itu titik 3 yang tulisan more di pojok kanan bawah. Nanti ada pilihan breakout di situ.
Sudah bisa Pak Firdaus? Silakan Bapak Ibu yang lain.
Oh maaf Bu Ruri.
Iya Bapak.
Bu.
Ya Pak Ade gimana?
Iya masuk paralelnya gimana ya?
Ini di breakout Bapak. Bapak di samping tombol record ada breakout room nggak? Mau kemana Pak?
Nggak ada tempat saya.
Mau ke tujuannya kemana Pak? Ruang apa?
Ke yang itu dari
Emily?
ruang apa ya Bu?
Temanya apa Pak?
Temanya yang ini, yang
Marine Science?
parallel session yang Emily ya, Just Pros.
Emily Hello Stoma ya? Boleh minta tolong Pak?
Iya, Dokter
Sudah Pak?
Emily.
Ya, dibantu ya Pak. Sudah. Ya, materi selanjutnya di breakout room Ibu Yayu.
Halo?
Ya.
Maaf, ini gimana, ini udah selesai apa gimana ya, Mbak? Atau udah di...
Sekarang ada di sesi paralel, Ibu.
Ya, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Gimana sih ini nggak jelas? Nggak ada suaranya, Bu. Hello, tes.
Halo, iya Ibu.
Gimana materi selanjutnya di mana, Mbak?
Maaf, Ibu mau ke breakout room yang mana?
Mana aja lah. Nggak tahu.
Ibu mau presentasi di mana?
Ibu presenter atau partisipan, Ibu?
Partisipan.
Partisipan, baik. Mungkin Ibu menghendaki ke Dr. Emily, presentasi Dr. Emily. Akan kami arahkan ke sana.
Bolehlah, kemana aja yang lagi mulai hubungan waktu.
Baik, Bu.
Pak Rani, aku dimasukkan di roomnya Bu Ani dong.
Oh iya, Bu.